Okay, so today we're going to continue with solving equations. The only thing that's going to be new is you might run into a special situation where your variables cancel out. All right, so if that happens, then you're going to look at what's left over. You're going to look at the remaining statement, which could say something like 8 equals 7 or 6 equals 6. All right, so we're going to look at the statement and decide, is that statement true or false? Okay, if the statement is true, so the one that would be true would be if you got something like 6 equals 6, then you're going to stop solving the equation and you say that it's either an identity, infinitely many solutions, or all real numbers. Kind of depends on the book that you have, or it depends on your teacher, and they might use different phrases, but it basically means any value of x would work. Right? If the statement is false, so like 8 does not equal 7, that would be a false statement, then the answer is no solution. Okay, so we're going to go through the problems. They're not all going to be special cases. Some are just going to be normal numbers, but we'll get to them when we get to them. All right, so look for distributive property. Combine your like terms on the same side. We don't have that, but we can move variables to the other side. So we have 9x plus 22 equals 31. Then we're going to subtract 22. So we have 9x equals 9. Remember, you divide by your coefficient, so you get x equals 1. Here we don't have distributive property, but we do have like terms, so we have 7x minus 16 equals 9x minus 15. Subtract 9x. We have negative 2x minus 16 equals negative 15. I'm going to add my 16 to the other side. So I get negative 2x equals 1. Then I'm going to divide by negative 2, and I get x equals negative 1/2. All right, so we're moving along quickly because I think this stuff should be review, and we just did it yesterday as well. So if I distribute, I have negative 8x minus 4 equals negative 2x minus 6 plus 9. Okay, now I'm going to combine my like terms, so we really have negative 2x plus 3 equals negative 8x minus 4. Then I'm going to add 2x to both sides. So I have negative 6x minus 4 equals 3. Then I'm going to add 4, so I have negative 6x equals 7. When I divide both sides by negative 6, you get negative 7 over 6. Remember, you can put the negative sign either on the top, the bottom, or the outside. I just usually put it on the top. All right, number 4, we're going to distribute. We get negative 6x minus 12 plus x equals 2 minus 8x minus 14 plus 3x. Now we have lots of like terms. So these add together. Negative 5x minus 12. I have 2 minus 14 is negative 12. I have negative 8 plus 3. That's negative 5x. And then I'm going to add my variables to get it to move to the other side. So I have, here's where we have a special situation. So negative 5x plus 5x, that cancels out as it normally would. Here I have 0 also. So I don't write 0, just my variables canceled. So what's left over? This is where I have a special situation. So this is your special case, number 4. Look at what's left over. Is it true or false? Negative 12 equals negative 12. That is true. So since it's true, then that tells me that I'm going to have infinitely many solutions. That's what I'm going to write down for here. Infinitely many solutions. Okay, so any value of x would really work for this problem. All right, number 5. So I'm going to distribute my 8. I have negative 7 plus 40 minus 24x equals 21 minus 27x. Okay, I'm going to combine my like terms. I have 33 minus 24x equals 21 minus 27x. If I add 27x to both sides, I have 21 here, and I have 33 plus 3x. Now I'm going to subtract 33, and I have 3x equals negative 12. And then last step is divide by my coefficient, so I get x equals negative 4. All right, here I have distributive properties, so I have y minus 4. Remember, when you distribute here, only distribute the negative 2. Keep the 6 there. So it's negative 2y plus 2. There's some like terms, so I have 8 minus 2y. And then I'm going to add 2y to both sides. I get 3y minus 4 equals 8. I'm going to add 4 to both sides, which is 12. And then I'm going to divide by 3, which was my coefficient, and I get y equals 4. All right, so flip over to the back. All right, number 7. We're going to distribute first. Okay, so we have negative 8x plus 6 equals 2x plus 6 minus 10x. I have like terms over here, so 2 minus 10 is negative 8x plus 6 equals negative 8x plus 6. So this might look like something is going to be weird since we already have the same thing on both sides. So add your 8x to both sides. That cancels, but this also cancels. So I'm left with 6 equals 6. So is this statement true or false? That's true. Okay, so I'm going to call this infinitely many solutions. And again, it might be listed as identity. It could say all real numbers. So on a multiple choice test, you should be able to recognize any of those as your answers. All right, number 8. This is a negative 1 that I'm distributing. If you need to write that in, go ahead. Just bring down the 4, though. So we got negative 5 plus x equals 6 minus 1 minus 4x. All right, now I've got some like terms. So I've got 2 x's, a negative 1. Over here, I have 6 minus 4, which is 2x minus 1. Now I want to move my 2x to the other side, so I'll subtract it. And I get negative 1 equals negative 1. Again, I have no more variables, so is this true or false? Just like in the last problem, it's true, so we're going to say infinitely many solutions. Okay? All right, so now, just like yesterday, we're going to set up some word problems. You have to write an equation, and then you're going to solve it. All right, so it says Jeremy receives an increase of 4% of his salary. So that means his salary is going up. 4%, remember, anytime we have 4 or any percentage, you're going to move it over 2 spaces to the left. So the decimal was there, so really it's going to be 0.04. All right, so if I want to figure out his increase, I'm going to do 42,000 times 0.04. Figure out what that is. So you could type that in your calculator. You get 1,680. So I'm just going to double check. 42,000 times 0.04. Okay, but it asks how much will he make next year. That's not what he's going to make. That's its increase. So I need to add that to 42,000. Okay, and then your final answer is going to be 43,680. So remember, if you start with the words, you have to end with words. So he will make $43,680 next year. All right, problem number 2. Ken figures that homecoming will cost him $160. If he has already saved $46 and earned $6 per hour at his job, then how many hours must he work in order to save enough money? All right, so he wants to get $160 total. How much has he saved already? Plus, he needs to earn a certain amount. So he's already saved $46. He's going to earn $6 per hour. So every hour, since that's what we don't know, that's our variable. So there's your equation. All right, so 160 equals 46 plus 6x. So if we move our numbers to the other side, 160 minus 46 is 114. And then divide by your coefficient. So if you do that, you get 19. Now, make sure you answer the question. How many hours must he work? So Ken must work 19 hours. All right, number 3. This type of problem, sorry, not number 3, the third word problem. Number 11 and 13, you're going to see these a lot. So you have a board. This board is 30 feet long. It's cut into 2 pieces, so it's going to be cut somewhere. One piece always needs to be called X, and then the other piece, it says it's cut into 2 pieces such that one piece is 3 feet smaller than twice the other. We're going to come up with an algebraic expression for this. So when we say 3 feet smaller than twice the other, twice the other is 2x. Smaller than means you're going to subtract 3 from that 2x. So we need to say these two pieces add together to be our 30. So the first piece plus our 2x minus 3 has to add together to give you 30. It helps if you draw a little diagram so you understand what the problem is asking. All right, so now you can just solve your equation. X and 2x is 3x. Add 3 to both sides. We get 3x equals 33, and then you divide by 3, and you get x equals 11. Now, it says find the length of each piece. So this is 11. This one's 2 times 11 minus 3, which is 22 minus 3, or 19. Okay? And if these are both in feet, so each, well, we'll say the pieces are 11 feet and 19 feet long. All right, and you can always go back and check. So is this one 3 feet smaller than twice the other? 11 times 2 is 22, minus 3 does give me 19, and do they add up to 30 feet? Yes. All right, this is going to be another typical problem that you'll see. So Julie has $212 and spends $8 per week. Her brother has $50 and saves $10 per week. How many weeks until they have the same amount? So we want Julie's amount to be the same as her brother's. So Julie has $212. If she spends money, she's losing money. She's losing $8 per week. There's our variable. The brother has $50, but he saves, so that means he's gaining money, $10 per week. All right, so now you've got your equation. You're going to move your variables over to the same side. So we have 212 minus 18x equals 50. If I subtract 212, I get negative 18x equals negative 162. And then if I divide by negative 18, I get x equals 9. How many weeks until they have the same amount? So it will take 9 weeks for them to have the same amount. Of money. Okay, and then our last problem is just like number 11. So you've got a 78-foot board. It's cut into 2 pieces. Remember, one of your pieces has to be x. Then read your problem to figure out what the other piece is. One piece is 2 feet less than 4 times the other. Okay, 4 times the other tells me I want to do 4x. Less than tells me I want to subtract that 2. Notice that I want to do 4x minus 2, not 2 minus 4x. So if you're doing 2 feet less than, you have to subtract the 2 after the 4. So that's a big mistake. Don't do 2 minus 4x. All right, those 2 pieces have to add up to be 78. So x plus 4x minus 2 is 78. If I add my like terms, I have 5x minus 2 equals 78, and then just solve the equation like you normally would. So 5x equals 80. Divide both sides by 5, you get 16. And then don't forget to go back and actually answer the question. So 16 is one piece. 4 times 16 minus 2 is 64 minus 2, or 62. So the pieces are 16 feet and 62 feet long. All right, double check, do those numbers add up to 78? Yes, they do. If I do 4 times 16 minus 2, so 2 feet less than 4 times the other, so 4 times that one is 64 minus 2, it really does give me 62. Okay? Oh, I almost forgot our secret word. So what should be our secret word for today? How about football? So make sure you write that down and turn that in tomorrow.